Hi students, this is Viswanath, Chemistry faculty for NEET and IIT exams. Today we are going to learn about quantum numbers. This topic is very important for objective exams, so listen carefully. See the numerical related to de Broglie wavelength. The wavelength of an electron accelerated by a potential difference of 500 volts is an electron is accelerated through this potential difference, then what is its wavelength? See this one. From de Broglie wave equation, lambda equal to h by mu. Instead of v, they consider u. Both are same. So where u is called velocity of electron, kinetic energy Ke equal to half mu square equal to E into voltage. E means charge of the electron and V is the potential difference. From this we can get U equal to square root of 2 into E into V divided by M. So substitute this in place of U in this expression, then we can get lambda equal to h by square root of 2m E V. H Planck's constant, M mass of the electron in kilograms, E charge of the electron, V potential difference 500. Substitute all these values, then we can get wavelength of the electron. So that is this. So what is the option? 10 power minus 11 means option A is the answer. Okay. See the next one. If the velocity of the electron in Bohr's first orbit is 2.19 into 10 power 6 meter per second, calculate de Broglie wavelength associated with it. Okay. So in the Bohr's orbit, first orbit, velocity is given. From that de Broglie wavelength we want. So we know that lambda equal to h by mv. Substitute h, m and v. Then we can get value, that is 332 picometer. Option C is the answer. Okay. Next, if E alpha EP represent the kinetic energy of electron, alpha particle, proton respectively. Each particle moving with the same de Broglie wavelength, then what is the relation? Which particle having more kinetic energy? So kinetic energy formula half mv square. In that, m is the mass of the particle. Here given particles are electron, alpha particle and proton. Electron mass is negligible, proton mass is considerable, alpha particle mass is more than electron and proton. So among these three types of particles, alpha is the heaviest particle and then proton and least one is electron. So kinetic energy is also related to mass of these particles. More mass, kinetic energy is less. Least mass, kinetic energy is more. So what is the order of kinetic energies? Expression C is the correct one for this question. Okay. Next. See the next one. Heisenberg uncertainty principle. What is the statement? It is impossible to determine simultaneously the exact position and exact momentum of an electron. An electron is revolving around the nucleus. Now, we cannot determine its position exactly. That means the exact position of the electron and momentum at the same time we cannot determine. If position is determined exactly, then we cannot say momentum of the electron exactly. If we determine momentum of the electron accurately, then position we cannot determine. So any one parameter we can determine, not both the parameters at the same time. That is Heisenberg uncertainty principle. Mathematically, expression is delta x into delta p greater than or equal to h by 4 pi. Delta x, uncertainty in the position, delta p, uncertainty in the momentum. Momentum means mv, product of mass and velocity. So mass does not change takes place, only velocity. Then we can write delta x into m into delta v greater than or equal to h by 4 pi. Then finally we can get delta x into delta v greater than or equal to h by 4 pi m. Now in case of numericals we have to consider equal to. So when we use this formula for numericals delta x into delta v equal to h by 4 pi m. Now see the conditions. If delta x is 0, that means uncertainty in the position is 0. That means the position of the electron determined accurately. Then delta v equal to infinity. See this. Suppose delta v equal to h by 4 pi m into delta x. Here delta x is 0. H by 4 pi m into 0. Anything divided by 0 means final value infinity only. So delta v equal to infinity. Suppose if delta v equal to 0, that means uncertainty in velocity is 0. So velocity of the electron determined accurately. Then delta x equal to infinity. Same. Delta x equal to 4 pi h by 4 pi m into delta v. In place of delta v substitute 0, then delta x we can get infinity. Okay, remember these conditions for objective questions, important. Next, the product of uncertainties is inversely proportional to mass of the particle. See this. This is uncertainty in momentum, uncertainty in position. The product of these are inversely related to, see this, uncertainty in velocity, uncertainty in position. The product of these values are inversely related to mass of the particle. Same thing we mentioned here. Suppose two particles A and B are given. For that, this one, delta x into delta V of particle A divided by delta x into delta V of particle B equal to mass of B divided by mass of A. Okay. This principle is mainly applicable for microscopic particles. Microscopic means electron, proton, neutron, atom, molecule. For these small sized objects, we can consider as microscopic particles. These Heisenberg uncertainty principle is applicable only for microscopic. See the significance means importance. It rules out the existence of definite paths or trajectories of electrons and other similar particles. In case of electrons present in the atom, according to Bohr's atomic model, Bohr proposed that, and also Rutherford also proposed that, electrons are revolving around the nucleus in a fixed circular paths. That means a definite path is there for the moving of electron inside the atom. But after proposal of this uncertainty principle, that type of definite path is not possible because we cannot determine moving electron position exactly. That's why we cannot predict the exact circular path of the electron. That is nothing but circular orbits are not possible. Exact definite paths are not possible. We can say probability of existence of an electron at a particular place. At this particular place around the nucleus, there is a more chance of existing electron. Here less chance. Like this, we can predict the possibility of the existence of electron. Okay. Next, see the numericals. When uncertainty in position and momentum are equal, then uncertainty in velocity is. Say this. This is the given condition. Uncertainty in position is equal to uncertainty in momentum. From this we can write this one. So from this. So we want uncertainty in velocity. Delta V equal to h by 4 pi m into delta x. In place of delta, instead of delta x, we can write this one. Then we can get this. Finally delta V equal to 1 by 2 pi 2 m into square root of h by pi. Option C is the answer. See the next one. The mass of a particle is 10 power minus 10 grams and its radius is 2 into 10 power minus 4 centimeter. Its velocity is 10 power minus 6 centimeter per second with 0.0001% uncertainty in measurement. The uncertainty in its position is delta x value we should calculate. For this given mass in grams, convert that into kilograms. Uncertainty in velocity delta v, how much percentage? 0.0001. So 0.0001 by 100 into 10 power minus 6. centimeter. Convert that into meters. That means we have to multiply with the 10 power minus 2. So finally delta V equal to 10 power minus 14 meter per second. See this. So this is the required formula for this. Delta X into delta P equal to H by 4 pi. Delta X we want. Substitute H value, pi value, M value, delta V. Then we can get uncertainty in the position. 5.2 into 10 power minus 8 meters. So this is the answer. Okay. Next important topic. Say this. Quantum numbers. These are useful to know the position of the electron, size of the orbital, energy of the electron in an orbital, spin of the electron in an atom. In a simple way, we can understand these quantum numbers. Suppose we want to write a letter to a particular person who is living at far distance. Then we want his name, street name, district name, house number, and state name. So by knowing all these details, we can write letter to a particular person. In the same manner, to get the complete information about the electron, what is the position of the electron, where electron is present inside the atom, what is the size of the orbital, what is the energy of the electron in that orbital, what is the spin of the electron in a particular orbital, all these things we can get from these quantum numbers. So here we have 4 quantum numbers. First one is principal quantum number, proposed by Niels Bohr. It determines the size and energy of the orbital. What is the size of the orbital? Small size or bigger size? What is the energy of the orbital? It is represented by n, values 1, 2, 3, so on, or capital alphabets K, L, M, N respectively. With increase of n value, principal quantum number increases, then size and energy of the orbital also increases. It also identifies the main energy level or shell. N equal to 3 means third shell, n equal to 5 means fifth shell, like this. Then total number of orbitals in a shell equal to n square. Main energy level contains orbitals. How many orbitals are present in a particular main energy level or main shell means 2n n square formula. See the example, n equal to 2. Then number of orbitals n square, 2 square equal to 4. 4 orbitals are present in second shell. Yes, 2s, 2px, 2py, 2pz. These 4 orbitals are present in the second shell. Okay. Next, the maximum number of electrons in an orbit, 2n square, where n is the number of orbit. Suppose in the third orbit, we want maximum number of electron, n equal to 3, 2 into 3 square, 2 into 9. That means 18 electrons are there. In the third shell, 9 orbitals are there, total number of electrons 18. So in this way, from this principal quantum number, we can get number of shell, number of orbitals and maximum number of electrons in a shell. Next, angular momentum of electron in an orbit equal to nh by 2 pi. Already same angular momentum we completed in Bohr's atomic model. So there small n represents principal quantum number. Next, number of subshells in a shell equal to n. N equal to 4. How many subshells are possible in the fourth shell? 4 subshells. 4s, 4p, 4d, 4f. Okay. Remember these points carefully. Related to these, numericals are there. Questions, multiple choice questions will come. This point and this one and then this. Okay. We will meet in the next class.